Hello and what's up guys? In this video, I will show you how I made the electrostatic chamber of my homemade powder coating gun. We'll also show you how I assembled and adjust the power supply, and later we'll test if it actually works. We'll test the gun to see if the paint powder sticks with the workpiece. So please stick around. And if you have not done yet, please do watch my video how I made the homemade powder coating gun. I'll leave a link in the description. And I highly appreciate if you subscribe to my channel, leave comments, and click the like button. You can see that I used the wheel spokes of the plastic toy car. This is to keep the wire conductor centered inside the PVC tube. The wire conductor inside the PVC tube or electrostatic chamber is actually a TIG welding filler wire. I would like to use copper, but at the moment this is the only material I can find. I decided to file a point at the end of the wire conductor. Thought it will help with the corona discharge. I drilled a small hole in the PVC tube where the wire conductor will be sticking out so that we can hook it to the power supply. You will see later. So the pointed end of the wire conductor in the electrostatic chamber stand out about 3/4 of an inch. The other end is bent 90 degrees. Cut to length so that I can slide it in the tube and have a small portion sticking out of the small hole. For the power supply, I bought the two major parts or modules from online shopping. The first one is the high voltage generator module. I think this one is originally used for tasers. The next major component is the DC to DC buck converter. This will give us the option to adjust the output voltage and current. It also has a built-in short circuit protection, so that if we accidentally touch the two high voltage outputs, it will not destroy the high voltage generator module. This is a very simple circuit diagram showing how I wired the main components. I housed everything in this outdoor electrical outlet box, which is a good size for the components. So there's the DC input jack where the positive wire goes to the small switch, then to the input terminals of the DC to DC buck converter. The output terminal is then wired to the input of the high voltage generator module. I connect the two high voltage output to these longer wires, about 3 feet long. Then the ends are terminated with alligator clips. The other extra modification I did with the DC to DC converter PCB board is to move the LED indicator light from the center of the PVC to the outside so that it is easily visible. I did that by soldering small wires from the LED pins back to the PCB board. I connected a 12-volt DC adapter to the input jack and made a quick test. We can see the high voltage arc in the output telling me that the circuit is working. So the next step we need to do is to adjust the voltage and current output that is supplied to the high voltage generator module. The DC to DC back converter board have these two potentiometers. This one is to adjust the voltage, and the other one is to adjust the output current. I will now adjust the output voltage to 4 volts. So at first I disconnected the high voltage module input and instead connected a resistive load to the DC to DC back converter. The load I am using is just a small 12 volts light bulb. So using a voltmeter connected to the output, I adjusted the potentiometer so that the voltage is 4 volts. You can also see the LED light up blue. I used a different meter to check the output current. The ammeter I'm using have a shunt resistor that I connected to the output of the DC to DC back converter, which essentially shorting out the output. This way, I can adjust the limit current that the DC to DC converter module will give out. When I turn on the circuit, you will see that the LED is now lit red, means it is in current limiting mode. I then turn the potentiometer and adjust the limit current to 2.5 amperes. The output current had a direct effect to the strength of the high voltage generator output. Now I'll show you how to test the high voltage output, whether it's positive or negative. So I went outside and looked for the earth grounding wire of the building. Then I test which of the output will have an arc jumping to the earth ground. This one did not, so let's try the other one. This one has the tiny little spark going to the earth ground. That tells me that this side is actually the positive output. Now for the fun part. Let us test the power supply unit with the powder coating gun. So I have this socket as a sample workpiece where I connected the negative end of the high voltage output. Then the positive end is connected to the central conductor of the electrostatic chamber. Let's see what happens if we blow powder to the workpiece with the power supply turned off. You can see that the powder just blows by the part but not sticking to it. I touched the workpiece to show you that there's no high voltage present. Now let's turn on the power and try again. With the electrostatic charge present, we can now see the powder sticking to the workpiece, the way it should be. There you go. The workpiece fully covered with powder. The back of the workpiece was not directly blown with powder, but you can see that some powder also stick to that side. The powder clinging on the workpiece even after we turn off the power supply. I am very happy with the results, and we are now ready to cure the workpiece on the oven. I did a quick and easy makeshift oven from scraps and start baking powder coated test piece. That will be on a different video, so please stay tuned for more. Thanks for watching and hope that you subscribe to my channel. Click the like button and see you next time.